like efficiently handle this type as compared to Hudi and Paimon for CDC streaming loads? And what should be the ingestion pattern? Like, what should be the tool that we should be using for ingestion in that regard? So, like two aspect. One is on the ingestion part. The other one is on the storage part, like solving the small file size problems and stuff like that.
Got it. Okay, so I guess I'll talk to you a little bit what was unique about Paimon and Hudi first, just to kind of put context. That the way I would think about it is that the two Hudi and Paimon were more focused on solving ingestion problems, while Delta and Iceberg were more focused on solving read problems. So in that regard, yes, I see like Hudi has a lot of different innovations on trying to really, and that's why like they specialize in sort of really low latency streaming ingestion. And oftentimes, like if that is like a must, ingestion into Hudi is oftentimes where people go. They'll use a service like OneHouse, and OneHouse will you use a Hudi-based ingestion and then use 𝗥table to translate it to Iceberg or Delta for consumption. Now, as far as like Iceberg and Delta, them having like primary keys, I mean, I assume it'll eventually happen. It's just like, again, I think their roadmaps and the communities have always been more consumption focused and making it a more focusing on the read optimization versus write optimization. But my assumption would be, at least for Iceberg, that eventually it becomes an index that you find in your Puffin files. That would, to me, be the most logical place to put it, because you can store it as binary. It'll be most condensed. You're not reading another file. You're just, basically, honestly, I think most new types of metadata indexes, anything, will probably just be more Puffin blobs going forward. Just that way, hey, you just open this one Puffin file, you iterate through the blobs, you use the blobs you need, and then that's just seems to be just a much more efficient pattern. I mean, again, there comes a point where, hey, what happens when you have too many blobs in there? Or the file becomes too big because it's storing so many blobs. But I'm sure we'll cross that bridge. So that would be my assumption there. I do think also I think semantic layer tools will be a good place for handling some of that. But again, that's more on the consumption side. Now, as far as like what tools to ingest, I don't have a particular opinion there, because it really depends on your ingestion patterns. And it also depends on sort of like who you have doing it, like in the sense that, like, are there going to be someone who's comfortable like managing a Flink deployment and writing Flink code and doing everything in Flink? Like oftentimes you're going to get the most flexibility using a tool, like Flink self-managed, but it also requires a lot more work on the top of in the part of your team, versus using something like Confluent, which is going to be manages a lot of the more complexities for you. You're still using Flink and Kafka under the hood, but it makes it a lot easier. Or using things like Red Panda, Rising Wave or whatnot, all these other streaming tools. I do think Iceberg streaming ingestion is going to be a sort of a big area that's being solved. In the sense, like, you can stream the Iceberg, like trying to figure out what's like who can do it the best. I think is currently a big part of what's going on in the market right now. That and catalogs would be the sort of like the two places, to me, I find like what's going on in Iceberg interesting.
Do you find talking to different people building these things across the world, do you find a lot of interest in low latency or real-time data pipelines? Because the analytical world traditionally it's always been batch, right? And not that long ago, these capabilities to build rather simple real-time pipelines have emerged. But when talking about this with different people, especially in the analytics world, I very often got the question, why would we care, right? Our stakeholders need a daily report or something like this. And so the question to you is, do you see an interest? Have you seen this need? Is this there at all? Or
for sure. I know there's a lot of people. I mean, I would say oftentimes it's going to be like financial companies where like real-time data really kind of makes a big difference. But I mean, I think a lot of times people focus a lot on trying to get to land the data real time and then realize, wait, can I actually run analytics on it real time? That becomes a bigger challenge. There's ways to do that. Like you can build things like, and then just run the analytics in midstream through Flink, depending on what your use case is. Like if I'm just trying to look at, hey, the last 5 minutes, I have a dashboard that shows me the last 5 minutes of prices. I can always just say, hey, let me go hit the stream, query the last 5 minutes worth of events with Flink, and then deliver that to like a dashboard or something. But again, how often do you need? Certain people need that. I would say probably most people don't. I do think a lot of people are trying to build that don't need it. You know, this is why, like in the book that I'm writing, Architecting Iceberg Lakehouse, there's a whole chapter just dedicated to asking these questions, like figuring out, okay, who are the people who are going to use this Lakehouse? What do they actually need? Figuring out what their SLAs, what were the challenges they've had before, and kind of doing that kind of audit before you just jumping on the thing. Like, you know,
I saw in a lot of Confluence communication, the theme that seems obvious is that low latency data is always better than high latency, because the value of data diminishes over time, right? Mm-hmm. And while I do agree, the question is how much it diminishes, and who actually needs this. Let's say we have a dashboard showing the consumption of our gas stations, whatever. And like, do we really need a second latency, or maybe the dashboard can have 15 minutes latency? How much does it cost, right? Because low latency always costs more than high latency. This is something that needs to be optimized for. And so I guess our world is still exploring which use cases really need it, and how much they are going to pay for it.
Another thing I've seen mentioned a few times is like, oh, they want to ingest the data faster, for like AI ML use cases. But I'm like, okay, well, if you're training your data as it's coming in that frequently, that's going to get really expensive really quick.